Here's another example where we want to find the binomial expansion of x minus 2 over x all to the fifth power. So again, we're going to try and use the Pascal's triangle to give us the coefficients and the actual expansion of this thing to the fifth power, and then we're going to plug in what the a and b is into that general expansion. So why don't we write down that general expansion first? A plus b to the fifth power. Now, you don't have to memorize this. As long as you can create Pascal's triangle, you can find whatever this binomial expansion is. So if I were to go back to my Pascal's triangle from the very first slide, you can create Pascal's triangle as long as you remember the pattern. That's always ones on the outsides, and the bottom numbers or the sum of the two are above it. If I want to raise this thing, the binomial, to the fifth power, I'm looking at the fifth row. And then all I need to do is look at these coefficients and remember that my a starts to the highest power, and then it's going to go down one every single term, and then my b is going to start with b to the 0 power, and it's going to go up one every single time. So, So basically, by knowing your row, by generating Pascal's triangle, you're getting the coefficients. And as long as you know the pattern of the powers of your a's and your b's, then that's really all you need to remember. So now that we're through that, let's go back to where we were for this example. So this is going to be expanded as a to the fifth plus 5 a to the fourth b plus 10 a to the third b squared plus 10 a squared b to the third plus 5 a b to the fourth plus b to the fifth. So that's quite an expansion. And this is one of those scenarios where I really don't want to have to spend all the time multiplying this out. I'd rather use something like this. So now let's keep track of what our a's and our b's are. So a is equal to this term right here, x, and b is equal to this term right here. And I'm going to carry that sign with it. So this is negative 2 over x. So if I plug this into my expansion here, when I expand raises to the fifth power, I'm going to plug in all the x's wherever I see a, and all the negative 2 over x's wherever I see a b. So we have x to the fifth plus 5x to the fourth times negative 2 over x plus 10x to the third times negative 2 over x squared plus 10 times x squared times negative 2 over x cubed, hopefully I have enough room here, plus 5 times x times negative 2 over x to the fourth plus, can I fit it? Negative 2 over x to the fifth power. Good enough. All right, so really, again, all that I did here is I am just plugging in a, or x, wherever I see an a. So there's an a, there's an a, there's an a, there's an a, there's an a. So I'm literally just mapping these a values. Oops. And just plugging in x in the appropriate spot. And then similarly, I'm doing the same thing with my b's. Wherever I see a b, I'm going to plug in negative 2 over x into my binomial expansion. So notice I've carried it along the powers and I've carried along the coefficients with all of these terms. So now we're just ready to simplify stuff. So here's my b, here's my b, here's my b, here's my b, here's my b. All right, so now let's simplify all this. It's time to condense this a little bit. So this is going to be x to the fifth plus 5x to the fourth times negative 2 over x. I'll simplify that a little bit further in the next step, plus 10x cubed. And this is going to be negative 2x times negative 2x. So this is going to be a positive 4 over x squared, plus 10x squared times, I cubed this, that becomes negative 8 over x cubed. And then this is going to be plus 5x times all of this to the fourth power becomes 16 over x to the fourth. And then this negative 2 over x to the fifth power becomes negative 32 over x to the fifth. All right, almost there. Last step. Let's clean this up one more time. X to the fifth plus, I multiply these two things together, and I'll get a negative 10. So actually, let's make that x to the fifth minus 10. And then this is going to be x to the fourth over x, so this is x cubed. And then next I'll have plus 10 times 4 is 40. And this is x cubed over x squared, so that's just going to be an x. Next I'll have minus, looks like, 80 x squared over x cubed, so that becomes over x. And then I'll have plus 5 times 16, so I think that's 80. And then I have an x to the first over x to the fourth, so that's over x cubed. And then finally, negative 32 or minus 32 over x to the fifth. So that one was a little bit more work than the previous example, but again, all that we're doing is we're plugging things into the right spot, using Pascal's triangle to give us these coefficients, and then simplifying. And then what we, again, to kind of notice the pattern, that should help us to see if we've done this well, at least with the powers. Here you can see I'm descending by 2 with every exponent. So this exponent is 5, then 3, then 1, then negative 1, then negative 3, then negative 5. So a little bit more work, but we can still do this thing. So why don't you try this example next? Pause the video, give it a shot, and see how it goes. All right, and here's my work for this one. Make sure that you got the same thing. If you didn't, go back and check your work and pause the video again, or go back, whatever you need to do.